Hi everyone. Today in this video we are going to learn about a new type of classifier which is basically used for classification purpose, and it is called rule-based classification. So rule-based classifiers are just another type of classifier which makes the class decision depending by using various if-else conditions or if-else rules. So let's see here in this slide. You have a condition, and this condition can give rise to a certain type of output. Here condition is called as conjunction of various attributes in a given data set, and y is the class level or the output which is to be predicted. So the condition used with the if is called antecedent, and the predicted class of each rule is called the consequent. And a rule can be formed as like this, in this way: rule colon condition tends to y. And here condition is the conjunction of the test attribute test conditions or antecedent or precondition, and y is the class level or the rule consequent. So if you see in this slide, this is an example of a rule based classifier using a given data set. So using the same rule, this condition tends to y, we can form a rule, and there can be set of rules based on the different set of attributes given here, the columns. So based on the values, if a certain mammal, we can consider the names or the mammal. So if someone gives birth, no, or they can fly, depending on the values, we can see that give birth is no, and can fly is yes. So we need to look for no, yes. Okay, give birth and can fly, yes. So this is a birds. So like this, there can be multiple rules which can be formed from the given data set. And here the condition is the left hand part. This is our rule R1, and left hand is the condition, which is also called antecedent, and this label to be predicted, that is birds, which is your output to be predicted, and this is called as consequent. So here in this slide, as you can see, um, rule R, a given rule R, it can cover an instance of S if the attributes of the instance satisfy a given rule. So if we consider all the rules that we saw in the previous slide, and attributes of two vertebrates, that is hawk. Okay, let's see here. Yeah, hawk and the grizzly bear. Okay, so we just have a simple data set like this in this table, and now we need to find out which rule it will cover which vertebrate is. Okay, so hawk has certain characteristics, grizzly bear has certain characteristics, so depending on that, which type of class do they belong to, here we need to make the classification based on that. So these are the different rules to be formed based on the previous slide rules. So if you see, the R1 covers the first vertebrae, that is no and yes for the give birth and can fly, because its precondition is satisfied by the given characteristics or the hawk um, attributes. And the rule doesn't cover the second vertebrae because grizzly bear can give birth and it cannot fly. So thus it's violating the given rule R1 that is provided here, the precondition R1. So this is how the rule-based classification is performed. Now let's see the rule coverage and accuracy. Okay, so a quality of a classification rule, it can be evaluated using various measures such as coverage and accuracy. So for a given data set that you see here in this table, if we take the data set as D, capital D, and a classification rule R, okay, where your condition is this: status equal to single and it tends to no. So if we take this status is equals to single as capital A, and y, that is no, as your label. then the coverage of the rule is the fraction of instances in the whole given data set that can trigger the given rule that we have here. So accuracy and confidence factor is the fraction of instances triggered by R whose class levels are equals to Y. Okay, so in terms of that, we can say that if here this is, let's take this status equals to single, this is termed as your A, capital A, and D will be the given data set, that number of instances are in the total whole data set. Then the coverage R will be equals to the probability or the coverage of status equals to single, that is A, divided by your whole number or total number of instances, that is D in the given data set. So A here will be considered as number of instances that satisfy rule antecedent, left hand part of the rule. And if you perform an intersection operation in between the A and the predicted level Y, then it will be your number of instances that satisfy both antecedent and consequent. And D will be equal to actually how many number of instances are there. So here in the data set, actually the coverage is 40%. And since the 4 of the 10 instances support the rule antecedent that we have here, single, 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 and the accuracy is actually 50% because out of 4 instances, only 2 are covered by the rule for the first one and this one, and these 2 are not covered by the rule. We are not getting the class predicted level as no, rather we are getting yes. Because of that, the accuracy is 50%. So here is one example of how does the rule based classifier work. Mm, so here for the lemur, turtle, and dogfish, shark. So these are some of the given rules. So lemur will trigger the rule R3. If you compare this, give birth yes, and blood type warm. Okay, so that is why it is satisfying the R3 rule. And the turtle actually it's triggering both the R4 and R5. If you can see the rule antecedent, you can find out the match here as per the table. And dogfish, shark, there is no match happening for any one of the rules that is provided here. So this is how the rule based classification actually work. Okay, so here in this case, in this given example, the turtle is triggering both the R4 and R5. Give birth, no. Can fly, no. Live in water sometimes. But by the order, so if there are two rules, so by the order, the conclusion will be actually a reptile. So as R4 is occurring prior to the R5. And we also didn't define a default rule before that. So in that case, if we have two matches, then we have to go with the first one. Then let's say rule ordering schemes. So you can refer to the data set here that is given. So first, let's say we want to find out in the let's just review what we have here. So in the rule based ordering, individual rules are actually ranked or ordered based on the quality, and quality means your accuracy and coverage. And the class based ordering, so if the rules belong to same class and they appear together, if you match all this set of rules, okay, for the rule based and class based ordering, you can find some of the rules provided based on the data set. You can make the comparison on your own. So first, finding out the accuracy and coverage of each rule. Let's see, consider this one. Refund, yes. Refund equal to yes tends to no. So if you compare it with the data set, the accuracy will be 100% and the coverage will be 30%. Okay. So for refund, we have yes. So for yes, we need to see how many classes are predicted as no. So based on that and depending on the accuracy and coverage formula, you can find out those details. In the same way, all these rules will they will have their own accuracy and coverage details. So accuracy will be 100%, coverage will be 10% for the second one. Then third one, so actually refund is equal to no, marital status is single and divorced, and taxable income is greater than 80. So for this, the accuracy and coverage will be 100% and 30% consecutively. So actually in rule based, the rules are ordered and ranked based on their quality and accuracy and coverage. Okay, you can also calculate it. I have also provided you the formula in the previous slides. So for each rule, try to calculate the accuracy and the coverage. And in the class based, the rules are separated or distinguished based on the classes yes or no. So here, yes and no are sorted in the order of decreasing importance. Okay. And somehow from this, we are still not clear about how the ordering criteria is being applicable. And there are also other ways which are further discussed in this chapter. So there are various advantages that the rule-based classifier has. So its characteristics is quite similar to the decision tree because like in the decision tree, you move from the root node to the leaf node for making a decision. In the same time, you go through the antecedent and then perform the classification to have the predicted class level. So mostly the idea is quite similar. It is easy to interpret and it is also highly expressive, explanatory as the decision tree. But its performance can be also, it can be considered as similar or comparable to decision tree. And it can also handle redundant or the duplicated attributes. So these are some of the advantages of rule-based classifiers. Try to review the slides where we get to calculate the accuracy and the confidence based on the given data set, its attributes, and the class level. And then let me know if you have any questions.